Lisa has been placed in charge of a project. She needs an estimate of how long the project will take. The project is made up of 5 activities: assemble team, manufacture hardware, write software, debug the software, and install the system. These activities are related by the following precedence diagram. Thus, the project duration will be the time it takes to assemble a team, plus the maximum of manufacturing the hardware on one hand and writing the software and debugging the software on the other hand, plus the time for installing the system. She believes that she can assemble a team in 10 days. The time taken to manufacture the hardware is uncertain. It could take anywhere from 60 days to 80 days. She decides that an appropriate model would be a triangular probability distribution with a mode of 70 days. The time for writing the software is also uncertain. It could take anywhere from 30 to 50 days. However, Lisa thinks that it is more uncertain than manufacturing the hardware. So she decides to model it using a quadratic function for the probability density function, which allocates more of the probability space to values away from the centre of the distribution. The time for debugging is the most uncertain of all. It might happen really quickly in 20 days, or it might take as long as 100 days. However, Lisa thinks it's most likely to take around about 40 days. Thus, she decides to model it using a skewed triangular distribution. After both the hardware and software are ready, it should only take 5 days to install the system. Lisa is not very good at calculus, so instead of using the inverse transform method to solve this problem, like any sensible person would, she decides to use an acceptance rejection method with uniform majorizing functions. Using 10 realization of a Monte Carlo simulation, determine the average time that this project could be expected to take, the upper quartile for this time, i.e. the time for which there is only a 25% probability that it will take longer, and the probability that manufacturing the hardware will be a critical activity, i.e. take longer than the 2 software activities. For assembling the team, we have a deterministic duration of 10 days. So that's simple, it's 10. For manufacturing the hardware, we have a triangular probability distribution. So this probability distribution goes from 60 days to 80 days, and it has a peak at 70 days. Now, in order to do our calculations, we need to know where this peak is. So we know that the area of a triangle, a half BH, equals, what's the area of the triangle? It must be equal to 1. B is equal to 20, so a half times 20 times H equals 1. Therefore, H equals 0.1. So we know that this is 0.1. Now, we're going to set up our majorizing function. So a majorizing density function in this case, to make life easy, we're going to choose a uniform distribution from 60 to 80. Therefore, we need to work out an envelope and increase that up to the peak. So our majorizing function will be y equals 0.1. So now we need to work out, using our good old-fashioned inverse transform method, random numbers that fit this majorizing density. So our majorizing density is simply a constant. So the actual majorizing density, of course, will have to be half of this, because that triangle is half of this, and for the majorizing density, the area must be equal to. Okay, our majorizing density is therefore from 60 to 80, 0.05, although this number doesn't really matter. What we're particularly interested in is the integral of this, which looks like so, where this is 1.0. And what we need to do is we need to then take the inverse of this line. So now we have something that looks like this. The x-axis way down there somewhere. And we need to work out the equation of this line here. So we know this point here is 180, and we know this point here is 060. So we have y equals mx plus b. Our slope will be 80 minus 60 divided by 1 minus 0, which gives us 20 divided by 1, which equals 20x, plus our y-intercept is 60. Okay, so we'll just transfer this over to here. So we'll use this formula to get random numbers between 60 and 80. Now once we have that, we need to work out our probability density function of those numbers using these two sloping lines in the triangle. Now that means we need to know these two equations. So let's work out this one. There's going to be two parts, one for the sloping up part and one for the sloping down part. So for sloping up, we have y equals mx plus b, which is equal to, well, our m, so what's our m equal to? It's our slope, is equal to, it's going up by 0.1 minus 0 divided by 70 minus 60. So, yes, 70 minus 60, which is equal to 0.01. So that's 0.01. Now we know at 60, 0.01 times x. Now we know at 60 that y is equal to 0. So 0 equals 0.01 times 60, which gives us b is equal to minus 0.6. Okay, so that's the rising part. So 0.01 times x minus 0.6 for x is less than 70. Okay, what about for the falling part? Once again, we've got y equals mx plus b. This time m is equal to, well, it's falling, so it's going to be 0 minus 0.1 divided by 80 minus 70, which gives us minus 0.01. So we've got y equals minus 0.01 times x plus. Now, we know that at y equals 0, x equals 80. So let's plug that in. So we have 0 equals minus 0.01 times 80. That gives us 0.8. So we can transfer this one down here. Now we can plug our numbers in. So the first random number, u1 equals 0.94737. So you can take this from the table of random numbers that I provided you with. So if u1 is equal to this, we plug this number into this formula to find out what is our x value between 60 and 80. So we're going to have x equals 20 times 0.94737 plus 60, which gives us 78.947. So now this number is greater than 70. So to work out f of x, we're going to use this lower formula. So f of x is equal to minus 0.01 times 78.947 plus 0.8, which is equal to 0.01056. So now we calculate f of x on g of x. Which is equal to this value divided by g of x, which is our majorizing function. Now that we have that value, we look up our next number on the table. U2 is equal to 0.87259. Then we compare these two answers. So what's happening is we've got a value which is around about here. When we look up f of x on g of x, it gets us around about here. But when we look up u2, that number's up here. The thing is, we don't want to be outside the triangle, we want to be inside the triangle. So therefore, we are going to reject this value of x. It didn't work. So we have to start again. So now we're going to look up the table again. This time we're going to use the third value. So we're going to set that as u1, which is now equal to 0.63856. So we're going to get x equals 20 times 0.63856 plus 60, which gives us 72.771. Once again, we calculate f of x, which is equal to, well, this is still above 70, so we're still using the second formula. Minus 0.01 times 72.771 plus 0.8, which gives us 0.072288. Again, we have f of x over g of x, which equals 0.072288 divided by 0.1, which is equal to 0.72288. Now, we need to compare this with the next u value. So we look up the table again, and this time we get u2 is equal to 0.66612. So what we've done is we've got an x value which is about 72. So our f of x on g of x is basically up here. u2 is below that. So therefore we're going to accept it. So that means we're going to use 72.771. So that means we're going to use 72.771 as our value for manufacturing the hardware. So now we need to move on to writing the software. So now we need to work out how long it takes to write the software. The probability distribution for writing the software is quadratic function going from 30 days to 50 days, which means there must be a peak at 40 days. Now, we don't know how high this quadratic function is once again. So what we need is the formula for f of x. Let's call the height h. So f of x is equal to, well, this is a quadratic centered on x equals 40. So we're going to have x minus 40 squared. In addition, it's upside down. So since 30 is where it's 0, so 30 minus 40 gives minus 10, squared gives 100. So we're going to have 100 minus this. Then, if we use this function, this would be up somewhere around near 100. So we're going to have to multiply that by h divided by 100. We still have the question of what is h. To determine h, we need to remember the area in here is equal to 1. So therefore, 1 is equal to the integral from 30 to 50 of 100 minus x minus 40 squared times h on 100 dx. So if you do this calculation and solve for h, you'll find that h is equal to 0.075. So now we know that f of x is equal to this times 0.00075. We need our majorizing density and our majorizing function, which will be like this. As before, what we're going to find is that our x value is equal to the lower bound, which is 30, plus the difference between these, which is 20 times our u value. Okay, so now what we're going to do is work out based on... So now what we're going to do is look up our table. We've used up 6 numbers, so up to our 7th number. So u1 is equal to 0.30712. So therefore, we plug it into this formula and we find x is equal to 30 plus 20 times 0.30712, which gives us 36.142. Now we need to work out what f of x is, so we plug 36.142 into this formula. So we've got f of x equals 100 minus 36.142 minus 40 all squared times 0.00075, which is equal to 0.063839. G of x was equal to h, so f of x on g of x is equal to 0.063839 divided by 0.075, which is equal to 0.85119. So 36.142 is around about here. This value here is around about here. So now we want to find out u 2. We look that up in our table. So we're up to our 7th number. So the next number is going to be our 8th number. So this is 0.69607. Now this is less than that. So what we're finding is it's down there. So it's inside the parabola. So since this is less than this, we can accept this value here. And now we can say that writing the software took 36.142 days. So for our probability density function for the debugging of the software, we have a triangular distribution again, which starts at 20, rises to 40, and then a tail, which goes out to 100. So therefore, our x value is going to be the minimum, which is 20, plus 100 minus 20, which gives 80 times our u value. So now we need to determine the equations of these two lines, which make up our probability density function. So our first one, in order to do this, we need to know how high is this? What's our height? Well, once again, we've got a triangle. So we've got a half times base, which is 100 minus 20, which gives 80, times our height equals 1, because it's a probability distribution. So therefore, h equals 1 on 40, which is equal to 0.025. 0.025. So now for this line, y equals mx plus b. So our slope m equals, this is rising, so we have 0.025 minus 0 divided by 40 minus 20, which is equal to 0.00125. So y equals 0.00125 times x plus, to work out b, we'll substitute the 0.20 into here and we'll find that b is minus 0.025, which is not surprising because 20 is halfway between 0 and 40, so we'll get the same y-intercept down here. Okay, so that's our first equation. For our second equation, we have y equals mx plus b again. Now m, once again, we're going from here to here. I'm going to call this 1 on 40 this time. So that's equal to 0 minus 1 on 40 divided by 100 minus 40. So 100 minus 40 gives 60, times 40 gives 2,400. So m equals 1 on 2,400. So this is equal to x on 2,400. But this is negative, so we have a negative here. Plus b, well, when we put in 100, 0, we're going to find that 0 is equal to 100 divided by 24, which gives 1 on 24. So we get plus 1 on 24. So that gives minus x on 2400 plus 1 on 24. So now we look up our table. We've used up 6 numbers, so we're up to the 7th number. So U1 is equal to 0.3 CVEN9701. So we substitute this into this formula and we get x is equal to 20 plus 80 times 0.37792, which gives us 50.234. So now we need to work out f of x. So this was the function for x is less than 40. This is the function for x is greater than 40. So this number is greater than 40, so we're going to use this function. So we get f of x is equal to minus 50.234 divided by 2,400 plus 1 on 24, which is equal to 0.020736. So f of x on g of x is equal to 0.020736 divided by 0.025, which is equal to 0.82944. So we've got a number which is somewhere around about here, and we're saying that this is 0.82. So U2, which will now be our 8th number, is 0.01488, which is somewhere down here, which is definitely in the triangle. So therefore, we'll accept this as our number for the time it takes to debug the software. Lastly, the time it takes to install the software is once again deterministic, and it's 5 days. So now we can put all of these together. We have a project that looks like so. We put our answers in. We have 10 days for this one. We have 72.77 days for this one. We have 36.14 days for this one. 50.23 days for this one. And we have 5 days for this one. So what we can see is that the time it takes the project, well, 50 plus 36 gives us 86, which is bigger than 72. So this is going to be our critical path. So our duration will be 10 plus 36.14 plus 50.23 plus 5, which gives us a total of 101 days, 0.38. Now, the next question we had was, is making the hardware critical? Well, in this case, the answer is no. So, that's once. Now we've got to do it another 9 times so we can get 10 different results. So, here's what the 10 different results look like. You can see that sometimes it took us up to 4 times before we could accept a random number. Once we've got all of these durations for our different activities, we can then work out what is the duration for the project overall for each of the 10 different cases, and whether the making hardware was critical. So now, to answer the final questions, the average duration is the average of the duration column. So we add up all of these numbers here, which gives us 1,121. Divide that by the 10 times that we did it, and we end up with an average duration of 112 days. The upper quartile is the median value for the upper half of the data. There's 10 data points, so the upper half has 5 data points. The median of these 5 data points is the third largest data point, which is 135.87 days. Finally, manufacturing the hardware was a critical activity in one of the 10 realizations, so the probability that manufacturing hardware will be a critical activity is 0.1.